side, it is just a statistical association. Statistical association means that if there is an exposure, the chance or the probability of an outcome will be higher. For example, when the color of trees are yellow or are red, the chance of common cold is higher. You know, there is a relationship between color of trees, color of the leaves of trees, and the chance of common cold. If there is green, common cold is less. If there is yellow or red, the chance of common cold is higher. But this relation is not causal. It means that if we changed the color of the trees, the color of the leaves of the trees, the chance of common cold will not change. But in the right side, the association may be causal. It means that by changing the first factor, the chance or the probability or the risk of the second event or the effect will also reduce. For example, relation between cigarette smoking and lung cancer. It means that by removing or by reducing amount of exposure to cigarette, the chance or the probability of getting cancer or getting any other lung diseases may also reduce. If there is not familiar for you, because the concept may be also new for you, I will ask the doctor to translate it in Arabic in a few sentences, please. Yes. Thank you.
اللي هو العلاقه بين الافكت والسبب. يعني اكو مرات بعض الدراسات انه احنا نلاحظ مثل التدخين والسرطان الرئه، اذا نوخر الكوست لازم المفروض الافكت يختفي او يسوي له كنترول محدوديه. بس مثلا اكو بعض الحالات شلون الالوان مال الاشجار هاي كومن كود هاي يعني ماكو يعني حتى اذا الشجره غيرناها لو شلناها ما راح تتغير، راح تبقى المشكله موجوده. تمام، انه هذا يشوف relation of association observed or not observed. صح عليك السؤال؟ ماكو هو يقول لك مرات دراسات بيناتها ربط نشوف انه اذا نوخر السبب يختفي الاثر او نسوي له محدوديه. مرات حتى اذا نوخر مثلا هذا الشيء فوق اللي هو يعتبر السبب تبقى المشكله موجوده. تمام؟
The ورق الشجر or leaves of the trees are related to common cold. But this relation is not causal. It means that there is another cause. What is another cause? This is change in season, that change in weather. By changing season from summer to winter, for example, both the risk of common cold and the color of the trees will be changed. So some relations are just a statistical relation. When the relation is not causal, we will call this a statistical relation. It means that by changing this factor will also change. But there is not any causal relation between them. Neither trees can change the risk of cold or getting common cold can change the color of the trees. There is a third factor that causes both of them. We will discuss this factor that is called confounder. We will discuss confounder variables in the next session. So we start from a statistical relation. And we will measure a statistical relation by means of risk ratio that we have discussed them, and another index that is odds ratio. There are two common indices that show the relation between a factor and another factor. If we are conducting cohort study, we will measure relative risk or risk ratio. If we are conducting case control study or cross-sectional study, we will usually measure odds ratio. By means of risk ratio and odds ratio, we will, uh, we will get a conclusion whether there is any relation between these two factors or not. If there is no relation, no further action is required. If there is relation, we should go further to observe whether this relation is causal or is not. Is not causal means that there may be a third factor or a third variable that is responsible for both events. Is it clear for you? Do you need any explanations or do you have any problem with this concept? Okay. I think there is no need to more explanations. The most powerful study design to show the causal relationship, as we have discussed last week, is experimental study or interventional studies. Because in interventional studies, we will classify or we will divide study participants in two groups that are exactly the same and just exposure is different. So any relation can be attributed or can be, due to exposure. Cohort studies are more powerful than previous categories, but not as powerful as interventional studies. And case control or cross-sectional studies, I forgot to mention that or cross-sectional. Case control and cross-sectional studies are the same in terms of statistical power, in terms of power, or in terms of evidence that produce for causal relationship. And available data means in descriptive studies, we've just described the situation. So this category, the clinical observations of a physician and descriptive, studies of available data just produce hypotheses. So they are producing hypothesis. What is hypothesis in Arabic? It's farziyah. These two types of evidence can just produce hypothesis. And the second category, from cross-sectional, case control, cohort, and interventional studies, this group evaluate hypothesis, whether their hypothesis is right or is wrong. Is it correct or is it not correct? Is there any association, any real association between these two factors, or there is not a real association? There may be a spurious association just due to confounding variable that we will discuss next session. I think it may be better to explain them in Arabic again.
تمام. هذول الدراسات الفوق نرتبهم من الدراسه الاقوى الاضعف للدراسه الاقوى. الاقوى بين الراندومايز اللي انترفنشنال تذكروها. الفوق هذول شو يسوون؟ البيربس مالتهم يعطينا بروديوسنج يعطينا نظريه عن كل شيء. لما يجي نجور لا يقيم النظريه سواء كانت صحيحه او لا. تمام؟ احد عنده سؤال؟ اللي فوق من الاقوى للاضعف للاقوى دراسات يسوون بروديوس يعطينا نظريه عن اضعف لان جوا يوضح لنا النظريه صحيحه.
Okay, thank you. As we discussed a few minutes earlier, first we try to see whether is there any association or not. If we observe an association, then the next step is to, to see whether this association is causal or maybe due to another factor that is called confounder. And as you can see in the bottom of this slide, we will discuss confounder in the next session after break. If there is a real association, it means that it may be causal. If there is a third factor that is responsible for producing disease and is also related with the exposure, it may be called a spurious association or a false association. It means that the association does exist, but this association is not causal. Association does exist means that by changing the first factor, the second factor also will be changed, but due to third or fourth or any other factors that they are responsible for changing both factors. In some cases, the association between a cause and a disease may be direct. Direct association means that there is no any intermediate outcomes. But in the real world, we usually have some intermediate outcomes. For example, hepatitis B virus may cause liver cancer. We know based on previous information, previous studies, that getting hepatitis B may increase risk of getting lung cancer, but there is not a direct relation between these two factors. After getting hepatitis B virus, some people may get chronic hepatitis. Then chronic hepatitis may cause cirrhosis. What is cirrhosis? Cirrhosis is a disease of the liver that the texture of the liver and the cells of the liver will be changed. Abnormal cells may replace normal cells of the liver, and then cirrhosis may cause to lung cancer. Or as another example, cigarette smoking may cause, for example, lung disease. But after tobacco smoke, the first event may be inflammation or minor inflammation of airways. Airways are the tube that connects outside air to the inner parts of the lung. Then after inflammation, there may be death of some cells. Some of the cells that are located in the inner wall of the airways may die due to exposure to cigarette smoke, and after this there may be degeneration of airways. And finally, this may produce chronic bronchitis. So there may be several steps between exposure and the disease. And as you can see in this slide, a factor may directly cause to it or ends to a disease, or a factor may produce another factor, an intermediate outcome. The first intermediate outcome may produce a second outcome. Both first and second outcomes are intermediate, and the last outcome may be death. The last outcome may be a disease. The intermediate outcome may not be, visible. Some intermediate outcomes are within the organs, and we cannot see them, we cannot observe them. We may need to use a microscope, we may need to get a sample from the liver, a sample from the lung to observe or to examine the intermediate outcomes. But the last outcome, that is a clinical disease, may be observed by physical examination or by any signs or symptoms. So when we are talking about causal relation, both direct and indirect pathways are included. And in other words, the indirect pathway is more common because there is not direct relation between an exposure and immediately a disease. In direct causation, a factor directly causes a disease without any intermediate step. But in indirect causation, a factor causes a disease, but only through an intermediate step or steps. And steps is more common because we have several intermediate, steps in producing a disease. The relation between a factor and a disease can be in 4 types or 4 categories. The first one is necessary and sufficient. Please give me a description of a necessary and sufficient cause. What is the necessary and sufficient cause? For example, I may say that factor X, if I believe that if X is related to Y, and in this type, what does this mean? It may be direct or it may be indirect. Okay, and necessary means that without having X, disease will not be produced. And sufficient means that just X is enough for producing the disease. So, necessary and sufficient means that for producing the disease, we have to have X. Without X, the Y will not be produced. And sufficient means that if we have X, X alone is enough to produce the disease. We do not need Z or M or N or O for producing disease. X alone is sufficient, and X is needed to produce the disease. This is not a true situation. In mathematics, we can talk about necessary and sufficient cause, but in the real world, I cannot, explain an example that some factor is both necessary and sufficient for producing the disease. We will return to this concept after explaining other issues. What about necessary but not sufficient? There are other factors that should be present to disease produces. Sufficient but not necessary. Sufficient but not necessary. It means that X can produce Y. but Z also can produce Y. So X alone can produce the disease, but Y alone also can produce the disease. So X is sufficient, but it is not necessary, because in the absence of X, Z can also produce the disease. So in sufficient but not necessary, it means that each of X or Z alone can produce the disease. Again, I think I need your help, please.
تمام. بس اول وحده necessity and sufficient. ما هو تقريبا واضحه. الاكس اذا فرضا اكس يؤدي الى واي يسوي لنا واي. necessary لازم اكس موجود. sufficient بس اكس، يعني زد ايضا ما يسوون، لازم اكس. هاي sufficient. necessary but not sufficient، يعني لازم اكس موجود بس ممكن مثلا زد يسوي، ممكن مثلا ام يسوي، اي واحد. sufficient but not necessary، ممكن اكس انه يسوي فلان مرض بس زد هم ممكن يسوي فلان مرض، يعني مو الا اكس نفسه موجود. تمام؟ واضحه؟ اكو واحد عنده سؤال؟
I'm interested in the relation between cigarette smoking and cardiovascular disease. Cardiovascular disease means diseases of the heart and the vascular tract. Smoking is one of these, belongs to which group of the these categories? Is it necessary and sufficient? No, because we know that not all smokers get cardiovascular disease. If smoking is sufficient for getting disease, it means that every smoker should get cardiovascular disease. But we know that there are many people who smoke for the whole lifelong, but they will not get cardiovascular disease. Necessary, is it necessary or not? This is not necessary, because we know many people may get cardiovascular disease, but they are never smokers. So cigarette is not necessary and is not sufficient. It belongs to the fourth group, neither necessary nor sufficient. It means that cigarette is a contributing factor. Contributing factor means that its presence will increase the chance of getting disease, and its absence will decrease the chance. There is always a chance of getting disease without exposure. When I say that without exposure to cigarette, there is a chance of getting cardiovascular disease, it means that cigarette is not necessary, because without it, there is a chance of getting disease. When I say that by smoking the chance will be increased, it means that it is not sufficient, because if cigarette smoking was sufficient, we expected that with smoking all people should get the disease. But we say that the risk of getting disease will be increased. So in non-communicable diseases, majority of causes are neither sufficient nor necessary. But for infectious diseases, in infectious diseases, the microorganism is, for example, in tuberculosis. For tuberculosis, the Mycobacterium is necessary, but is not sufficient. We need exposure to Mycobacterium tuberculosis. Without Mycobacterium tuberculosis, no case of tuberculosis will occur. But many people may be infected with this microbe, but they may never get the disease, because for getting tuberculosis, we need other factors. For example, immunodeficiency, malnutrition, background disease of the lung, and in fact, about 1/3 1/3 of the total population in the world are infected with Mycobacterium tuberculosis. It means that if we have 60 people in this class, on average, 20 of us will have exposure to Mycobacterium tuberculosis. 1/3 of people in this class have Mycobacterium tuberculosis in their lung, but they never will get the disease, because for getting disease, we need other factors. The most important one is difficulties in immune system, malnutrition, repeated lung infections. By repeated lung infections, for example, repeated common cold, after repeated common cold, the immune status of the lung may be changed. So for infectious diseases, there is a necessary cause, but not sufficient. What about for common cold? We need a virus of cold, to produce common cold. It is necessary, but it's not sufficient, because many people may have contact with the people who had cold, but they may not, they will not get the disease. So for infectious diseases, the biological factor or the microorganism is necessary but is not sufficient. For non-communicable diseases, almost all factors are neither sufficient nor necessary. When we talk about a risk factor of a disease and we say that physical exercise protects against cardiovascular disease, it means that for remaining healthy, having physical exercise is not necessary and is not sufficient. It means that even we do exercise regularly, it does not guarantee that we will 100% will remain healthy. Or in other terms, if we do not have physical exercise, we may remain healthy. It means that physical exercise is neither a necessary nor a sufficient cause for remaining healthy, or vice versa. People without physical exercise have a higher risk of getting disease, but it does not mean that people who do not exercise 100% will get the disease, and people without having, and people who do people who do physical exercise regularly, it does not guarantee that they will never get the disease. Okay? Is there any problem with sufficient, necessary, and neither of them, or both of them? Do you have any ambiguity, any questions? Yes, or not? I provided two examples. In the first scenario, the outcome is remaining healthy. We discussed the outcome may be disease, maybe death, maybe recovery from a disease, or maybe remain healthy. So if the outcome is being healthy, then physical exercise, having physical exercise increase the chance of being healthy. Okay? We know that if we do, regularly, if we do regularly exercise, it means that the probability that we remain healthy is higher. But if we do not have physical exercise, does it mean that we will get the disease in 100% of cases? No, because there are some people with quadriplegia. What is quadriplegia? Paralysis of both upper and lower limbs. People with paralysis of both arms and both legs are called quadriplegia. They cannot do any physical exercise, but we may find some people with quadriplegia without cardiovascular disease. It means that physical exercise is not, a necessary cause for remaining healthy. Or in another example, we may talk about what's the meaning of sedentary life. Stay in the office, or he may go to the work by using car from the garage to the garage. Some people just go to the garage of the home and then by car go to the garage of the workplace and then go by the elevator to the office and again return by the elevator. This is called sedentary life. Sedentary life equals to not having active transportation. Active transportation means transport by walking or by bicycle. Not active or inactive transportation means transportation by motor vehicles. We know that sedentary life is a risk factor for cardiovascular disease. But you may find many people with sedentary life without cardiovascular disease. It means that sedentary life or nothing have physical examination is not sufficient for producing disease. And in other cases, we may find some people without this factor, without sedentary life. It means without sedentary life means that they are active. We may find some people without this factor who will get the cardiovascular disease. So it means that physical activity or not having physical activity is not necessary for producing disease and is also not necessary, it is not also sufficient for getting cardiovascular disease or prevention of cardiovascular disease. I will repeat it that if the outcome is protection, no factor is necessary for prevention of the disease, and no factor is sufficient for protecting from getting the disease. We may be interested in protecting from hypertension. Another example. We know that salt may increase hypertension. You know that if we increase the amount of salt in our food, the risk of getting hypertension is higher. But salt alone is not sufficient for getting hypertension. Some people may use, a huge amount of salt, but they may not get hypertension. So it is not sufficient. And it is not necessary for hypertension. What does it mean? I say that salt is not necessary for hypertension. What this sentence does mean? Yes. Exactly, thank you. They may find many people with hypertension. In fact, majority of cases of hypertension are essential hypertension. Essential hypertension means that we do not have any knowledge about the cause of hypertension. More than 80% of hypertensive disorders have unknown causes. Unknown causes means that they have hypertension, but we do not know which factor or which factors may produce this disease, which factors may increase the risk of disease. So salt or consuming salt is a risk factor of getting hypertension. This risk factor means that people who consume high amount of salt have a higher relative risk of getting disease. higher relative risk. It means that risk of getting hypertension in people who have exposure with salt is higher than risk of people without consumption of high amount of salt. Or if we conduct a cross-section or case control study, we may talk about odds ratio of hypertension in people with high amount of salt. It means that by exposure to salt, the odds ratio or the risk ratio of hypertension will increase, but it is not necessarily the cause of hypertension, and it is not sufficient for producing hypertension. I just try to mention that there is not a one-by-one relation between causes and diseases. In mathematics, there is a one-by-one relation. In mathematics, we know that 2 plus 2 equals 4, nothing else. In mathematics, we know that if we add 2 by 2, we will reach to 4. And there is no, other answer for this equation. But in epidemiology and in biostatistics, A may produce B or may not. In epidemiology, in biostatistics, A is not necessarily, a cause of B, or B is not necessarily produced just by A. So, when we have some ambiguity, some huge amount of ambiguity about the cause and effect, how can we decide whether cigarette smoking is a cause of cancer or not? It is a major problem. How can we decide whether there is a relation, when we saw a relation, whether this relation is causal or not? We have some criteria for this decision. Later slide just describing the necessary, sufficient. Just for example, factor A plus B and plus C can produce the disease. In this case, neither of them are sufficient. It means that A needs B and also needs C to produce disease. So A is not sufficient, B also is not sufficient, and C is not sufficient. But the combination of A plus B plus C is a sufficient cause. It means that if we have A, B, and C, the disease will if we have a combination or a complex of A and B and C, then the disease will occur in 100% of situation. It means that neither of them is sufficient, but combination of them or the complex of them is a sufficient cause. If A can produce the disease, or B can produce the disease, or C can produce the disease, each of them is a sufficient cause. It means that A alone can produce disease. A does not need B or C. B again does not need to A or C because B alone can produce the disease. In this case, A, B, or C, each of them are a sufficient cause of disease. If we have three combinations or three complexes that each of them can produce the disease, each of these three categories can produce the disease, and there is no other complex or no other combination of factors, A alone cannot produce, but A plus B can produce the disease, C plus D can produce the disease, E plus F can produce the disease. What is A? What is the role of A in this example? Is it necessary? Is it sufficient? Or none of them? None of them. What about A plus B? It is sufficient. Suppose that I change one factor. I changed D by B and E by B. In this case, thank you, exactly. B is necessary because by removing B, the first factor is, removed. The second factor is also removed, and the third factor will also remove. So in this example, in the modified example, B is necessary. It may be a good example for infectious diseases. That, for example, Mycobacterium plus immunodeficiency can produce TB, tuberculosis. Mycobacterium plus repeated infection of lung can produce tuberculosis. Mycobacterium plus malnutrition can produce tuberculosis. Just as a hypothetical example. It is a hypothetical example. If there is a cause that is common between all complexes or between all complex factors that can produce a disease, this factor is necessary, because by removing this factor, neither of these factors or neither of these complexes, this combination can produce the disease. Thank you for answering this question. Is it clear for you? Any questions? I'll try to answer the question. How can we decide whether a factor can be regarded a cause of a disease or not? We have some criteria. We will call them criteria for causality. In different books or different references, you may find a different list of criteria. But the textbook that we have used for our course, the Gordis, selects 9 criteria. So we have 9 criteria. Each criteria, existence of each criteria can increase the probability of causality. These are 9 criteria. We will briefly introduce each criteria. What does temporal relationship mean? It means that for a factor to be regarded as a cause, it may exist before the disease appears. If we have a study and our study is capable to show that first the factor produced, existed, and then the disease occurred, then this study is capable of showing the temporal relationship. You know that we have case control, cross-sectional, and cohort studies. Which one can produce the temporal relationship of exposure and disease? I will repeat my question. We have 3 main categories of observational studies: case control, cross-sectional, and cohort. Which study design is capable to show that exposure is before outcome or not? Cohort. Because with cohort design, we start from having or not having exposure, then we will follow the people to see whether they have disease or not. What about cross-sectional study? In cross-sectional studies, we will again return to our 2x2 table: exposure, present and absence, outcome, presence and absence. Which cell is the starting cell of a cross-sectional study? Thank you very much. Total. We have a total sample. We will get a random sample from the population. Then we will ask them whether they have disease or do not have the disease. And at the same time, we will ask them about which one have exposure and which one does not have exposure. We can then have 4 cells. We may talk about the probability or frequency of having exposure in cases. What's the probability of having exposure in cases? We have A plus C cases. Okay, the cases are A plus C, and we know that A of them will have the exposure. So we can say that this fraction, or is it a ratio or a proportion? Is it a ratio or proportion? This is a proportion. Why?
Because the numerator is part of denominator.
Exactly. Thank you. Thank you very much. Because the numerator is part of the denominator. We can say that this proportion of cases have exposure, but we cannot judge which one comes first. We cannot say that first people had exposure, then get the disease, or first the people got the disease and then had exposure to the risk factor. Because we ask the questions about having disease and having exposure at the same time. We will not follow people. Without follow-up, we cannot judge which one comes first. For judging about the temporal relationship, the cohort studies are preferred, because in cohort studies, we start from this one. In cohort, we start from a group of healthy people who had exposure, and as a control group, a group of, again, healthy people without exposure, and after follow-up, a proportion of exposed and a proportion of unexposed population will get the disease. Will get means that first the exposure existed, then the outcome occurred. Is it clear? Do you need any more explanations in Arabic? Please raise your hand. Okay, thank you. So, temporal relationship means that it is clear that if a factor is believed to be the cause of a disease, exposure to the factor must have occurred before the disease developed. Ladies and gentlemen, please turn off your mobiles, put it on flight mode. If you have an important task and you expect for an important call, please silence your mobiles, and after calling, go out of the class, because by each ring, all students will be distracted. If there is a temporal relation, it does not mean that the relation is 100% causal. Please pay enough attention to this section. If there is a temporal relationship, if the cause appears before the disease, it does not mean that is necessarily a cause. It just means that it can increase the chance of causal relationship. If there is an opposite direction, it is against the causality. If I know that people with cancer started to smoke, in some cases, there is no relation between the smoking and cancer. Suppose that there is a cancer without any known relation with the smoking. But after getting cancer, people start to smoking because they believe that they will not live for more than 1 year. And they decide, so please enjoy our rest of life. Please start smoking. So in some cases, the disease may occur before start of exposure. If we believe that first people get cancer, then started to smoke, it means that the relation between exposure and disease is in the opposite direction. It is called, what is the name of this relation? Reverse causality. It is called reverse causality because the direction is from disease to the exposure. If the disease occurs before exposure, it is against the causality. It excludes the causality. But if the exposure comes before, if first we have smoking, then disease, it does not say that smoking is 100% responsible for cancer. It just says that the first criteria has a positive mark. We need another criteria to get the positive mark yet. So the first criteria increases the chance, increases the probability, increases, the belief that it may have a causal relationship with the outcome. What about the second criteria? A strength of association. The strength of association is measured by the relative risk or odds ratio. The stronger the association, the more likely that it is the relation. It is a causal relation. I have two tables. Smoking again, and hypertension, smoking, smoking, and lung cancer. Suppose that we have 1,000 smokers and 1,000 non-smokers in a cohort study. Cohort study means that we have 2,000 healthy people, 2,000 people without hypertension. Half of them were smokers and half of them were non-smokers, but all of them were disease-free because it is a cohort study. And we noticed that, for example, 120 of them get hypertension during follow-up, and 880 remain healthy in the smokers, and 100 from non-smokers again get the hypertension, and 900 remain healthy. What is the relative risk or risk ratio of getting hypertension in smokers compared with non-smokers? What is the RR? First, we have to calculate the risk of disease in the smokers. 120 divided by 1,000. It means 12%. Okay? 120. We had 1,000 healthy people who used to smoke. 120 get the disease during follow-up. So the risk or the chance or the probability of getting disease is 120 divided by 1,000, or 12%. What is the risk of disease in non-exposed people? 10%. And what is the relative risk? 1.2. It means that smokers have a 1.2 times higher risk of getting the disease. Suppose that we have again 1,000 smokers and 1,000 non-smokers. After some 10 years of follow-up, 10 of this group will get lung cancer and 990 remain healthy. From non-smokers, 2 get the cancer and 998 remain healthy. What is the relative risk in this situation? %1 divided by 0.2%. Okay? Or 5 times. It means that smokers have a 5 times higher risk of getting disease. So we judge that the relation between smoking and lung cancer is much stronger than the relation between smoking and hypertension. although the risk of hypertension is much higher than risk of getting cancer in exposed population. We noticed that 12% of smokers get the hypertension or hypertensive disease, but just 1% of smokers get lung cancer, although the risk of hypertension is much higher than risk of lung cancer in the smokers. But we know that a large proportion of non-smokers also get the disease. So the difference between risk of exposed population and non-exposed population for hypertension is, less strong, is weaker than the relation between lung cancer and smoking. Again, آقای دکتر من میخوام اینو بیان بکنم که بالا بودن ریسک در مورد فشار خون برای گروه مواجه یافته دلیل نمیشه که این یک عامل قوی هست. آنچه که برای من مهمه اینه که نسبت به گروه کنترل مواجه یافتگان نسبت به مواجه نیافتگان ریسکشون اختلاف چندانی نداشت. اینجا اگرچه ریسک خیلی پایین بوده در هر دو گروه، بیماری خیلی نادرتر بوده، ولی مواجه یافتگان 5 برابر مواجه نیافتگان. بنابراین من به این عدد نگاه نمی کنم که ریسک کدوم بیماری بیشتره، بلکه نگاه میکنم ریسک بیماری نسبت به مواجهه نیافتگان یا گروه کنترل کجا بیشتر بوده. و چون این 5 برابر این 1.2 برابره، میگم strength of association for lung cancer is much greater than the strength of association for hypertensive disease. Thank you.
شباب ردوا وياي. هذا هنا جاي يحكي على قوة الفاكتور نفسه اللي احنا جاي نحكي عليه، اللي هو حاليا السموك، وهل تأثيره على المرض الفلاني والفلاني اللي هنا رايح على الهايبرتنشن ولا. هنا الاستاتيكم اللي تعرفون كلش مهم الفرق بين هذين الاثنين. الفرق بين المعرضين والما معرضين. هنا طلع لنا من قسمنا طلع لنا 1.2 تمام. هنا من قسمنا المعرضين وعلى غير المعرضين طلع لنا 5 اضعاف. فمعناته شنو هو؟ تاثير الفاكتور بالسموكينج على اللنج اقوى. ليش؟ لان شو اسمه الفرق بين الاكسبوز والنون اكسبوز طلع 5 اضعاف، 5 اضعاف اللي يدخنون شو اسمه يعني يطلع عندهم الكانسر اكثر من اللي ما يدخنون. بس هنا 12 على 10 اللي هي بالهايبرتنشن 1.2، فالفاكتور شويه مو قوي ارتباطه بالجسم ما بين الاكسبوز والنون اكسبوز. فشنو هو هسه احنا هنا المهم الاستاذ اللي يركز عليه انه نشوف الفرق بين المعرضين والغير المعرضين ونقارنهم بين الفاكتور الثاني الجدول الثاني حتى نعرف يا هو. هسه هنا باعتبار طلع لنا 1.2 هنا طلع لنا 5 اضعاف، فمعناها اكيد ارتباط السموك بالكانسر هوايه اقوى.